这没有拍到冒烟的地方吧？
啊。
都站到这上吗？
啊，
这边要不要放地下呀？
哦，买这个。
茶班要不要放地下？
这还有一个啊，来。
这边还有个好茶嘞。
有鼠标，拿鼠标没？
果要用电脑的话，就是是。
喂。稍等，应该没关系。
可以开始了。有声音吗？
准备开始吧。
好，
像昨天一样，
好。Dear friends of Beston, welcome to the live show. This is Vivian from Beston, and I'll be glad to the host today to introduce you the whole production of our production line of the carbonization unit. Okay, before the introduction, please have an overview of our plant. Okay, 做一个全景，做一个全景。Okay, now let's have a close look at it. Okay, follow me, please. So you will see here, this is the silo. The silo is used to store for the temporary storage of the feedstock of the biomass. Yeah. Okay. And you will see. So what kind of biomass is suitable for the carbonization unit? We have two requirements. So firstly, we need the moisture of the raw material to be within 15%. And secondly, we will need the size of the raw material within 20 millimeter and better 8 to 12 millimeter. Okay, so you will have a look at it, the raw material today. What we are using is the rice husk. The rice husk is the rice husk. We tested the moisture. It's within. It's about 9 to 12%, and of course the size is within 20 millimeter. So it's suitable for direct feeding. So let's take a close look at it. Okay, 看一下。Okay. Okay, after okay, later we will start the feeding, and this is the large belt conveyor which is used to convey the raw material later. As you will see, it is allocated with the compartments, so the raw material can be conveyed here evenly and uniformly. Okay, follow me. And here you will see the raw material will enter into the top of the airlock. The airlock there. Yeah, you will see the one that marked in yellow. The airlock is a safety device. The airlock is a safety device which is used to prevent the air from entering into the carbonization reactor. So it's very safe. Okay, after the raw material enter through the airlock, it goes through the carbonization unit directly. And for the carbonization reactor, we have two cylinders designed. Firstly, the raw material will enter into the inner cylinder of the reactor, and then it travels from one end to another end, and then it then drops into the outer cylinder and travels back to the feeding side. So you will find that the feeding side and the discharging side, they are at the same side. Okay. From the you will find that from the beginning feeding to the end charcoal discharging, it will take about 20 to 25 minutes. Okay. Okay, now we will have a look at it, the whole carbonization unit. 照一下主炉，照一下主炉。对，从这边一直照。Okay, so how the charcoal, the end product, the charcoal will be discharged later. You will see there are two sides of water-cooled screw discharger, and the screw discharger, both of the two sides water-cooled screw discharger are equipped with dual layers. The water recycling in it, and the water can cool down the temperature there, and so you can get the end product charcoal in a normal temperature. It's about 30 to 35 degrees centigrade. Okay, later you will see the end charcoal comes out from here, just here. Later we will see it. Okay. Okay, so besides the end charcoal, the end product, the biochar, and other end products else. Okay, yes, of course, biogas. So what is the application of the biogas? Of course, the biogas, for one part, it will be heated. It will be recycled to heat the carbonization itself, and for the surplus biogas, it will be burned out in the burning chamber. Okay, so you will see the yellow part, the yellow pipes. It's used to travel the biogas, and the biogas, you will see it clearly that it will be traveled through the yellow pipes to the burning chamber. Okay, The yellow chamber, you will check it. 黄色的管道 ，OK。
哪几公？
哦，激光笔，激光笔，激光笔，激光笔，激光笔。
有几个问题，这个金料尺寸，然后跟大家说一下，在这里面。
金料尺寸。
你可以把那个给那个。
你说已经有问题了是吧？
你不用撤回了，你就。
Okay, you will see the blue part. This is used to convey the biogas. Okay, for the rest part, the surplus biogas will be burned out in the surplus biogas combustion chamber. Here, this one. Okay, this one. Okay. So you must be curious. What is the exhaust gas will be used for? Where is the exhaust gas goes? Yes, of course, it will be discharged, and it will be discharged environmental friendly, and of course, so how it is discharged? It will get through. It will get 3 steps before it gets discharged. Okay, the first one is the cyclone deduster. The exhaust gas will firstly go to the cyclone deduster to get the dust removed, and secondly, it will go through the flue condenser to lower the temperature down, and after that, it will go through the water. It will go through the water spray tower with the water spring purification and the ceramic ring adsorption. And after that, it will get emitted environmental friendly. So now let me show you the cyclone deduster. Okay, you will see here the cyclone deduster here. Yeah, here. Okay. And you will also see the flue condenser. So where's the flue condenser? Okay, let me show you the flue condenser here. Okay, this is the flue condenser. Okay, after the flue condenser, the exhaust gas will also go through the water spring tank, and you will see. Following my laser point, you will see the water spring tank there. Okay. Yeah. After that, it will be get emitted environmental friendly. Okay. This is the whole part of the carbonization unit. So our customer must be curious that how big the line area it is for the demo machine. Currently, I will let you know that our demo machine, it takes the length 20 meters, and the width 7 meters, and the highest point is about is at the location of the airlock point, and it is about 4.6 meters. That is here. Follow me here. This is the highest part. Okay, this is the highest part. This is the highest part. Yeah. Yeah. The length is about. The length is about 20 meters, and the width is about 7 meters. Yeah, that is the rough information for your reference. Okay, if you have any question, just put your comments on our comment area. Thank you. Okay. 有问题没？有问题没？
Hello everyone, this is Ariel from Beston Group, and I'm the hoster of today's live show for the carbonization plant. And I found that there are some comments with the question of our carbonization plant. So firstly, I will answer the questions and then begin the introduction of our work process of the machine. Firstly, the question for the design to work both with electricity and LPG. Okay, let me introduce you with our machine's design. For this carbonization plant, it will require the electricity to run it, but it will also require some fuel oil or gas or LPG for preheating the reactor. You can see that there are some heating field there because the machine requires to heating, so it will require some fuel for heating it. So LPG will be required, and the electricity will also be required. And for the input material capacity, for this machine, it's just a demo carbonization plant, and the capacity of this machine is 200 to 300 kg per hour. It's the capacity of this machine. But we have different models of the biomass carbonization plant, such as 1 ton input capacity per hour, and 3 tons input capacity per hour, and 5 tons input capacity per hour, and also the skin mounted 100 kg input capacity per hour. And for another question, what do you mean with environmental friendly? It means that there is no any pollution from our carbonization plant, the whole system. And for the legislation of the company, okay. Actually, you know that the limitation of different countries' environmental protection requirement is different. So it's better to provide us your local environmental protection requirement for running this machine. and then we will provide you the solution to comply your local requirement. Another one question from earlier, I don't know if I read it correctly. Do you provide any training for technicians and maintenance? Yes, we will provide our engineers to your local to provide you the training and the installation guidance in your local site if you need. Okay, now we solve your questions in the comments, and now we begin to introduce our work process of the carbonization plant from the feeding system. You can see that there is the silo for the rest husk. Today we will use the rest husk as a material, and the size of the rest husk is about 3 to 5 millimeter, and the moisture of the rest husk is 9 to 12%. And they will be fed into the conveyor by they will be fed into the reactor by the conveyor. And you know that for Beston's carbonization plant, we recommend you to use the material for the biomass with size less than 20 millimeter, and 8 to 12 millimeter is best, and also the moisture less than 15%. If you cannot maintain your biomass material in this range, we can provide you the dryer and crusher to help you to make sure the raw material can meet our requirements. Okay, I got that there are some questions. How many total power need? Actually, for different models, the power required is also different. Can we see how you connect your LPG to fuel the carbonization? Just to use the LPG burner to heating the carbonization. That's okay. Very easy. We will provide you the burner according to your fuel. If you want to use oil, we will provide you the oil burner. If you want to use LPG, we will provide you the LPG burner. All the gas, you want to use the gas, we will provide you the gas burner. In South Africa, we can design the LPG burner according to your local LPG requirement. Okay. So let's go back to the work process of this machine. Now the rest husk is feeding into the carbonization plant, and you can see that there is a big angle belt conveyor, and there is a airlock valve which can prevent the air enter to the reactor, so that for the carbonization plant it is running in no oxygen situation, so that the running will be safe and more stable. And now we go to the carbonization system. You can see that our carbonization plant is very long, and for this model, the length of this machine is about 12 meters. And for Beston's carbonization plant, we have a special design, double cylinder and double chamber. You can see that there are two chambers, which can ensure the stable and a range operation and combination for the biomass. And the double cylinder can make sure the biomass be fully pyrolyzed and to be produced to biochar. When the material feed into the reactor, the rest husk will directly enter to the inner layer and go this way. The rest husk will go to the back of the inner layer and then dropped into the outer layer, and then go back this way. And during this process, the charcoal will be produced, and the bell charcoal will be discharged from this part, from this position, and the belcher will go from the water cooling discharger and then be discharged, be stored at there. Why we use the water cooling discharger? To reduce the temperature of the belcher. By the water cooling discharger, the temperature of the belcher will be reduced, and the under belcher's temperature is about 30 to 40 degrees, so that we can directly to touch them very safe. Okay, let me see if the questions. LPG and electricity power. How many power required to run the machinery per hour? Danish, for your question, our colleague will answer you in the comment, because there are many dates. Okay. And let's go on. Let's go on with the work process of this machine. Now you have got the belcher, and in the next part, I will introduce you the bell gas. And you can see this part, this pipe. This pipe is for the bell gas. The bell gas will be produced from the reactor and go from this pipe and enter to the second digester firstly, and then it will be cleaned. So you will get the clean bell gas, and the clean bell gas will go back to the reactor, the combustion chamber of the reactor, by the yellow pipes. By the yellow pipes, they will be recycled as the heating fuel to heating the reactor. Because we design the carbonization plant combustion chamber for using the bell gas as the heating fuel, so that you can save most of the heating fuel for yourself, so that you can save much money for the fuel. Normally, you need to preheating the reactor before operating it. Normally, it will require 1 to 1.5 hours to preheating it. And after the preheating, the bell gas will be produced, and you can directly to heating the bell gas as a fuel, so that when bell gas produced, you will not to use your own fuel. And for the now the belcher is produced, and we can see it. 给我一点。有点声，有加声。You can see the temperature of the belcher is very low. I think it's about 30 degrees. I can directly to touch it. And now we're back to the bell gas. For the bell gas, normally from 1 ton of belcher, 1 ton of bell mass material, you will get about 0.7 ton bell gas, which means that about 70% of bell gas will be produced. The quantity is large. Let me see the questions in the comments. Is the plant is fully automatic? Yes, our carbonization plant is fully automatic, and it's continuous design. It can running for 24 hours per day. It's recommended to run it 5 days per week, and it cannot stop to working continuously. Can we see fuel and burners that you currently using here? Now you can see this part. This is the biogas burner. This is a biogas burner because now the preheating is over and biogas is produced. So we use the biogas as the heating fuel, and this is the biogas burner. And there is also the biogas burner because we have two chambers for the combination plant. What's the final moisture of the belcher? We can check it by the machine after the belcher is produced constantly, stably. What's the best temperature required for carbonation? As this machine can produce at normally for the carbonation plant, the carbonization temperature is from 380 degrees to 450 degrees. And for the furnace of the carbonation plant, the temperature is about 450 degrees to 500 degrees. Can we see the final product? Yes, you can see the final product. Do this machine produce the byproduct vinegar? Actually, we can collect the wood vinegar. We can collect the wood vinegar by the condenser system, but for our demo carbonation plant, we didn't equip it with the condenser system. Now let's go to see the final product, the belcher. 可以吗？
灯光。哦，放在有灯光的地方，来，可以放这儿。
This is the end product belcher. Because now it's just begun to work, so the carbonation plant, the carbonation is not so stable and not so complete. How belcher is cooled to 30 degrees. By the water cooling discharger, you can see there is two water cooling dischargers. This one and this one water cooling dischargers. Because in the water cooling discharger, there are some water. In the side of the outer cylinder of the water cooling discharger. There are some water, so that by the power of the water, we can cool down the temperature of the belcher. Okay, let's go on to our work process of this carbonation plant. Now I have introduced you the end product belcher and the end product biogas. And now we talk about the exhaust gas. You know that during the whole process of the carbonation, some exhaust gas will be produced from the reactor and go from this pipe and this pipe, and go this way into the cyclone deduster, and be cleaned. And then the exhaust gas will enter the condenser, the flue condenser, for cooling down the exhaust gas. And then the cold exhaust gas will enter to the deduster system. And by the deduster system, the exhaust gas will be cleaned and cold. And then the white and clean gas will be discharged from the chimney. And for the deducting system, because different countries has different requirements for the environmental emission, so we recommend you to provide us your local environmental requirement so that we can design the corresponding solution for the deducting system for you. Now let me double check the comment. What did you use to run the carbonation machine before it generated biogas for reuse? Before the biogas is produced, we use the oil as the preheating fuel. Create a demo. Please give if you give the clue. How many biochar is produced from 1 ton of biomass? Based on the moisture of the biomass material is 10%. Normally the biochar yield will be about 30%, which means that from 1 ton of biomass you will get about 0.33 ton biochar. Did you use diesel or LPG, and how much did you use before generating biogas? As I mentioned, we are using the diesel before the biogas is generated. Just for today, we use the diesel as a heating fuel, as a preheating fuel. The preheating will require 1 to 1.5 hours. Okay, now there is no new questions in the comments, and then my colleague Vivian will come back and to host the carbonation plant live show. See you later. Bye bye.
Okay, today this is a really exciting moment. And we have our customers from India and in Indonesia come to our site for the live show. They are so enthusiastic. So let's have their opinion about this their visiting. Okay, okay, this way. Hello, Mr. Move.
Hi.
Hi, how are you? I'm good. What about you?
Yeah, nice.
Okay. You're from India?
Yeah, we are from India.
Oh, welcome.
Thank you
And
very
this is Asad?
I'm Isaac.
Oh, okay. Thank you. Welcome. Welcome.
Thank you.
Yeah, okay. So you will say something to the friends of Beston who are watching the live show.
Okay.
Yeah, say hello.
Hi. Hello. Hi.
Yeah, where are you from?
We are from India.
Yeah.
And we have a lot of coconut shells.
Okay.
And many other products that we wanted to carbonize.
Okay.
So we are speaking with Beston for maybe a year time.
Okay.
And now
Yeah.
we decided to visit directly.
Oh, welcome.
You have the testing already running. So when we
Yes.
come here, we can see this.
Yeah.
So that we can able to decide.
Yeah.
What is the difference.
Yeah, that'd be good.
Okay.
Yeah.
It's okay.
Oh, okay. Okay. Oh, okay.
Okay.
So, it's my great honor to show you from the beginning to the end. Okay. Okay. So this is our silo. It is used for the temporary storage of the raw material for the biomass, and the biomass used for our carbonization plant. We have two requirements for it.
Okay.
The first one is its moisture. It must be within 20. It must be within 15%, and the size must be within 20 millimeter.
20 millimeters.
Yes, yes, and of course 8 to 12 millimeter is better.
Better.
Yes, yes, exactly. And so today what we are using is the rice husk.
Rice husk, okay.
Yes, and of course the size is within 20 millimeter. And the moisture we tested is about 8% to 12%.
Okay.
Yeah, so of course it's very suitable for direct feeding.
Okay.
Yeah, you can take a close look at.
Yeah.
Yeah. Okay. Yeah. 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 Okay. It's very dry, right?
Yeah, very dry.
Yeah, it can be direct feeding.
Yeah, yeah. Okay.
Yeah, and for this part, this is the belt conveyor. This is the large angle belt conveyor to transfer the biomass.
Okay.
Yeah. Okay. And as you will notice that there is the compartments located with the belt conveyor. So the function of this, it can convey the raw material evenly and uniformly way to the next step.
Okay.
Okay.
Good.
Okay. Here. Yeah. Okay. Let's come here.
Yeah.
You will see the raw material. The raw material comes to the top down. Yeah, the feeding system, the top of the airlock.
Yeah.
So the airlock is a safety device. It can prevent the air from entering into the reactor. So it's very safe.
Yeah. Okay.
Yeah. Okay. And after the airlock, it will drop into the carbonizer.
Okay.
So the carbonizer here we have. Okay. This way, please. So our carbonizer, it has double cylinders.
Okay.
That means there is an inner cylinder and as well as the outer cylinder.
Okay.
And firstly, it will enter into the inner cylinder.
Okay.
And it travels from the feeding end to the other end.
Okay.
And then travels and then drops to the outer cylinder and travels back to the feeding end.
Oh, okay.
Yeah. So you will find that the feeding end and this is the discharging end. You will find that the feeding end and the discharging end are the same end.
Ah, okay.
Yeah, yeah. So how is the material? How is the bell char discharged? You will see here from the airlock, the charcoal will firstly drop into the airlock.
Yeah, okay.
And the airlock is the same function. It's the same function to prevent the air from entering in. So it's very safe. Yeah.
Okay.
Yeah. Okay. And then it travels by these two sides of water screw discharger.
Okay.
Yeah. The water-cooled screw discharger. Both of them are equipped with dual cylinders.
Okay.
With two tubes. So inside it is the recycling water. It can cool down the temperature of the inner charcoal.
Okay.
So you will get the inner charcoal with a normal temperature.
Okay.
Yeah, here you can see it. Okay. Okay. Yeah. Yeah, you can touch it. You can touch it. Yeah, you can touch it. Yeah, you can touch it. Yeah, yeah. Yeah. Yeah, we can have a comparison with the raw material. Okay, here, this way. Okay. Yeah. It is fully carbonized. You see?
Yeah.
Fully carbonized.
Yeah, yeah.
And then there is no smell. It is completely carbonized.
Yeah.
Okay, this is good.
Got you.
Yeah. You already started this period for this project for a period of time, and you will see.
Okay.
It is good.
Yeah, it is good.
Okay.
Very good.
Yeah. Okay. Okay. So here.
Okay.
So this is the charcoal discharging part. So you will also focus on the end product. So besides the bell char, what is other the products of the carbonization unit? That is the biogas.
Okay.
Yeah, the biogas here. The biogas will be used recycling to heat the carbonizer itself.
Okay.
You will see here So for this, you will see the yellow
Pipe.
Yeah, the yellow pipe. All the yellow pipe is used to transfer the biogas.
Okay.
Yeah, this part
Okay.
and this part,
Okay.
this part.
Okay.
Yeah, and
Which means the gas which is getting produced internally is again used for the same purpose.
yes.
So you don't use the external energy. You use the internal energy.
Yeah, we'll use the energy for part to heat the carbonizer itself, but it also has the surplus gas.
Okay.
The surplus biogas will be burned out here.
Okay.
Yeah, this is the surplus gas combustion chamber.
Okay.
Yeah, this is the chamber.
Okay.
So we will burn the exhaust gas in this chamber.
Okay. And
Yeah.
This gas is used for what purpose?
Currently, it just burn out. But if you have other purpose, we can design. Yeah, we can design with your purposes.
I see. Okay.
Yeah, yeah. And the last step is about our exhaust gas. So
Okay.
where the exhaust gas goes,
Okay.
you will see here.
Okay.
Yeah, this is the pipes. Yeah,
Okay.
yeah, the pipes
Okay.
here and here
Okay.
and here to
Okay.
transfer exhaust gas.
Exhaust. Okay.
Yeah,
Okay.
the exhaust gas. They firstly will be transferred through the cyclone deduster.
Okay.
The cyclone deduster is used to remove the dust of the exhaust gas,
Got it.
firstly.
Okay.
And after that, it will transfer to the flow condenser.
Okay.
The flow condenser is used to cool down the temperature of the
Cool down?
exhaust gas.
Okay.
Yes, yes.
Okay.
And after that, after the temperature is cooled down,
Okay.
it goes through to the
Cooling tower.
the cooling tank, the water spring tank.
Yeah. Okay.
Yeah, water spring tank. Yeah, here. So let's take a look at it.
Yeah, okay.
Yeah. Yeah, you will see. You will see that part. Yeah, that part. That is the water. That is the water spring tank.
Okay.
And within it, the exhaust gas will get purified with the water spring,
Okay.
and also the ceramic ring absorption.
Okay.
And after that, it will get emitted, environmental friendly.
Okay.
Okay.
All right.
So is it clear for you?
Very, very, very clear. Thank you very much.
Okay.
Okay.
Welcome
Thank
to
you.
us. Okay. Okay. So let's see if there is any question. Okay. Okay. Let's see. Any question? Any question? Oh, hello. Hello. This is friend. Oh, this is friend coming from Indonesia. Say hello.
Hello, David.
Hello, friend. Hello, friend. Yeah. Say something to the friends all over the world who are watching our live show.
Hello, everybody.
Where you are from?
Beston live show. I'm from Indonesia.
Okay.
Yeah, we're looking at the carbonization plant. Very good machine.
How long have you started this project?
We are just beginning, actually.
Oh, just beginning. Oh, this is a very prosperous project. Yeah, okay. If you have any question, we have our engineer here. Yeah, to give you a better service. Okay, have a good day. Okay. Okay, just like check the questions, whether there is questions. Okay. Huh? Okay. Please have a look at it, the overview.
everyone, Ariel is back. For the questions in the live shoe room, of raw material to feeding chip, wood, and strip. Actually, for all kinds of biomass material, all kinds of biomass can be used as a material for our carbonation plant, such as sawdust, wood chips, coconut shell, rice husk, and so on. So many kinds of biomass. And for the price of the machine, please contact with your sales consultant, or you can email us, and we will provide you the price of the model you need. What's the temperature of biogas? Actually, we didn't judge the temperature of the biomass, but the heating value, because we use it as a fuel. And normally, the heating value of the biogas is about 2,800 kcal. Okay, if you have any other question, please write down in our comments, and when I got it, I will answer you. And by the way, for the last question from Kenneth, let me double check. For the LPG cylinder, you mean that in South Africa you have 48 kg of LPG cylinder. So we want to know how we can connect it. Let's go this way. Let me show you how our diesel tank connect with our burner. As there you can see this is our diesel oil tank, and this is a pipe, and this is a pipe for the oil tank. The oil tank will by the pipes to connect with our burner for the carbonation plant. Easy to understand? If you have any other question, please write down in our comments, and I will answer you when I got it. And now I will introduce you the whole work process of our carbonation plant by this demo machine. Firstly, I need to introduce you this machine. The capacity of this demo machine is 200 to 300 kg per hour. This is the input capacity of this machine. And before operating it, we have preheating it for 1 to 1.5 hours. And we use the diesel as a preheating fuel. We use about 30 liters of diesel as a preheating fuel for preheating the carbonation plant. And today, we will use the rice husk as a raw material. And firstly, I will introduce you the feeding system and introduce you the rice husk. This is our feeding system, and you can see there is a silo of our rice husk material. Why we use the silo? Because silo is more suitable for liquid raw material, such as rice husk, wood chips, and sawdust. And by the silo, you can fully automatic to feeding the rice husk. Just by the silo, the rice husk go from the silo and go into the feeding conveyor belt. And let me see the rice husk. Today we use the rice husk with size 3 to 5 millimeter, and the moisture of the rice husk is 9 to 12%. You know that for Beston's carbonation plant, we recommend you to use the biomass material with size less than 20 millimeter and 8 to 12 millimeter is best, and the moisture need to be lower than 15%. If you cannot to maintain your material in this range, we can provide you the dryer and shredder to make them to meet our requirement for feeding. And now the rest husk is feeding into the carbonization plant, and the height of the conveyor is 4.6 meters, and the rest husk will go through the airlock valve. The airlock valve can prevent the air enter to the carbonization plant reactor, so that there is no oxygen in our carbonization plant. So we can make sure the safety and stability. Okay, now let's go back. Let's go to the carbonization system. You can see that this is our carbonization plant. And for Beston's carbonization plant, we have a special design for the double cylinder and the double chambers. This is the first chamber, and this is the second chamber. And we equipped it with 3 points to hold the main furnace, so that the machine will be more stable and more safe for running. And the inner layer and the design of inner layer and the outer layer will make sure the biomass be fully carbonation. And now the rest husk is feeding into the inner layer by the airlock valve, and directly enter to the inner layer. The rest husk is directly to enter to the inner layer, and go this way. The rest husk material will go to the back of the inner layer, and then drop into the outer layer of our carbonization reactor. And during this process, the charcoal will be produced. Actually, the whole process will take about 15 to 20 meters, and then the belcher will be produced and be discharged from this position. And the belcher will be discharged from the water cooling discharger. This is the first water cooling, and this is the second water cooling. By the water cooling discharger, the belcher will be cooled down, and the temperature of the under belcher will be about 30 to 40 degrees. And now you will get the belcher at there. Let me see the belcher produced. This is the belcher produced. The similar shape and size of the raw material rest husk. You can see this is the raw material rest husk, and this is the rest husk charcoal. Okay, now let me check the questions of our comments. And now I have explained you the feeding system and the carbonization system. Later I will introduce the other systems. Do Beston machines meet European and California emission standard? Yes, Beston can provide you the solution to meet the Europe and California emission standard. But firstly, you need to provide us the European and California emission standard for checking. We will design the corresponding emission system according to your local requirement. Okay? Building with bodies. Hoping my answer has solved your problem. Okay, now we back to the next system. for the biogas system. Now you have got the biochar from our combination plant, and then I will introduce you the another end product, biogas. Usually the biogas will be produced from the reactor and go from this pipe, and the biogas will go into the cyclone digester firstly and be cleaned at there. Then the cleaned biogas will be go through this pipe and go back and go to the yellow pipes and go back to the combustion chamber of our carbonation plant. And the biogas will be burned as a heating fuel at there. You can see this is the biogas burner. And this is the first chamber of our combination plant reactor. And in another side, this is another biogas burner. By using the biogas, you can save some your own fuel. Normally, 1 ton of biomass will produce 0.7 ton biogas, which means that about 70% of biogas will be produced. And normally 70 to 80% of biogas will be burned as a heating fuel for recycling to using for this carbonation plant. But the excess biogas will be burned in our combustion chamber. Go as there. This is the excess biogas combustion chamber. Okay, now we have explained the biogas system, and there is no questions in the comment now. So let's go on to the exhaust gas system. This and this, the two pipes is the exhaust gas pipes, and the exhaust gas will be produced from the reactor and go from this pipe and go to the cyclone digester system. And then the exhaust gas will be first cleaned at the cyclone digester, and then the exhaust gas will go into the flue condenser system. By the flue condenser system, the exhaust gas will be cooled down, and the temperature of the exhaust gas will be reduced. And then the cold exhaust gas will go into the dedusting system. By the dedusting system, the exhaust gas will be cleaned and be cooled, and then the clean and white gas will be discharged from the chimney. Regarding the emission questions, because different countries has different environmental emission standards, so it's better to provide us your local government emission standard, and then we will design the corresponding solution for your local emission system, for your local emission standard. Okay, let's go to the questions as a comment. What is the recommended maximum operating hour per day for this machine? For this question, actually, because Beston's carbonation plant is designed for continuous working 24 hours per day, so you can running it without stop for 24 hours per day. Can you show the exhaust part? I want to see how clean the air that has goes through the final stage of the. Actually, because this is a demo carbonation plant, so the dedusting system is just for sample using. So the dedusting system is not so so convenient to show there because the light because the light in the deducting system is not good at now. Based on your product capacity, what is the total cost of final product, which include labor, fuel, water, electricity, material, and maintenance? Danish, for your question, because we have different models with different capacities, our sales consultant can provide you the return on investment sheet according to your local market information, if you can provide us. So if you have the project sales consultant now, you can contact with your consultant and he or she will provide you the return on investment document for reference to help you better understand it. If you have not contacted with anyone of Beston's team, please contact with our office website, and later our colleague will contact with you. Okay. Okay, later our colleague Vivian will come back and talk about the machine with you. See you later, bye bye.
Okay, dear friends, thanks for Ariel's explanations. Okay, now let's continue with the questions. Okay, here, one friend is asking about the emission issue. I wanted to see how clean the air that has gone through the final stage of the particle suppression system. Okay, okay, okay. So I will show you the final stage, how the clean air comes out of it. Okay, okay. This way, please. Okay.啊，这个管道它是从哪儿出去的？从这上面。Okay, you will see the exhaust gas will comes from the water spring tower and then enters into the chimney. From here, it will go through the chimney. So let's take a look at it, the chimney. Oh, here, as you see, this is the outlet of where the exhaust gas comes out. So there is no smoke. There is no smoke there. You see? Okay. 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 Yeah. Here. Okay. Here. Okay. So there. Okay. So let's look at the other questions. How long the time process from the raw material input to charcoal, and the temperature during carbonization. The time from the biomass feeding to the charcoal discharging, it normally takes about 20 to 25 minutes. Okay. Okay, next part. The temperature for the carbonization, for biomass carbonization, the temperature is about 380 degrees centigrade to 450 degrees centigrade. Okay. The next question: what is the lifetime of this machine if run 24 hours? Normally, our machine is about 8 years. Yes, it can run 24 hours continuously because we are our machine is continuous carbonization plant. Okay. Next part, how about the maintenance of the carbonization chamber? Is there any problem with charge? The maintenance, we have our engineers, professional engineers to guide you after your installation and of the machine, and in your operation period, our engineers will give you the professional guidance. So no worry about this. And also we have the maintenance brochure for you to get you step by step. Okay. So how many hours can this unit run continuously in a year? Normally, our machine can run 5 days a week. 5 days a week. So times 24 hours. That is 120 hours. One week. So there are 4 weeks in a month. You just so you times 4, and then you times the weeks. That how many weeks in a year, then you can calculate. So the normal hours is about 5,000 and about 5,500 hours. Okay. How much energy system needs per hour? Okay, so for the energy, it depends on the model of different carbonization units. Normally, the fuel, normally the energy is only consumed in the. We say that the fuel is only consumed in the preheating period. It's about 1 to 1.5 hours. We have 4 models and different consumption. And you can tell us which model you prefer, so we can calculate the fuel for you. So how many countries use your system? Well, our carbonization unit has sold all over the world, and you may check our sales list, and you may contact our project consultant, and you will know the digital countries that we have sold. Okay. Wow, see, there are so many customers. They coming to the site of the carbonization unit, looking the site show. Okay, see here. Okay, so now let's feel the temperature of the discharging system. I think many customers are curious about this. Is it safe? And is the temperature high? Okay, just follow me and we feel it. For the screw discharger is dual tubes, so it's very safe to touch it. It's cool. The cooling water just runs through this tube, so it's very safe. Okay. Okay. Let's see the charcoal. Oh, it's almost full. It's almost full here. See. Oh. Okay, let's see the charcoal. It's completely carbonized. Okay. Okay, now, is there anyone who want to know the process again? Okay, give some comments on the comment area. I will check it. Oh, there is a question. Do you have any system in Europe? Yes, of course. We have our plants. We have exported. Already to UK, to sorry. To wait a moment. 我记不住了，快点。好。 说我是负责物流。
Hello everyone, I'm Ariel, I'm back. Because I'm responsible for European market. So for Ola's question, do you have any system in Europe? Let me answer you this question. Actually in Europe, we have many sets of combination plants is running, such as Finland, and Croatia, and Serbia, France, and Croatia, and also US. How large is the footprint for the BST-50 pyrolysis plant? Hello, Tom. You mean the land area required for BST-50 plant, yeah? The land space for the BST-50 plant is 30 meters length and 15 meters width, and the height is 8 meters. For robot shoe, yes, please show me if there is smoke. Point the camera down the light to the final part where the smoke comes out. Vivian has shown you the smoke part from the dedusting system. There is no smoke. There is no smoke produced from our machine. Have you seen it? What's the maximum kg that we can send and provide for chill? We recommend you to do the laboratory test for the combination plant if you want to send us some material for test. Because the biomass material is difficult to send to China, because China's customers clearance is difficult for this kind of material. So it's recommended you to send us 5 kg biomass material for laboratory test for the combination plant. Is there If there is no other question, I will introduce you the work process of our machine again. Firstly, a brief introduction of our carbonization plant. For Beston's carbonization plant, it's recommended to process the biomass material with size less than 20 millimeter. 8 to 12 millimeter is best, and the moisture needs to be less than 15%. If your material cannot meet the requirement, Beston can provide you the dryer and strider to make sure the size and moisture can meet our requirement. And for the Beston's combination plant, it's fully continuous design, and the machine can running 24 hours per day. And for Beston's combination plant, there is a special design different with the competitors. It's double cylinders and double chambers and 3-point to holding the reactor. The 3-point to holding the reactor can maintain the stable operation, and the double cylinders can make sure the combination will be more complete and varied. And for the double chambers for heating, it can also maintain the stable and fully combination. Ola, this system you show us is BST10. Actually, no, Ola. The demo, this side of demo combination plant is not not same as the models we sold now, because it's just designed for test, just a demo combination plant. This model's capacity is 200 to 300 kg per hour for the input capacity. It's not same as BST10. BST10's capacity is larger than this demo machine. BST can process 1 ton biomass per hour input per hour. And for this machine, from the feeding of raw material to the biochar production, the whole process will take about 15 to 20 minutes. If there is no other questions, I will introduce you the work process of the combination plant again. For the combination plant, before the operation of it, you need to preheat it firstly. You need to preheat this machine for 1 to 1.5 hours. And you can use heating fuel such as diesel, heavy oil, LPG, or gas to do the preheating. And when the biogas is produced from the combination plant, you can stop your own fuel to heating the reactor and begin to use the biogas as the heating fuel, so that you can save most of the fuel cost to running this machine. Is there any other question, Ola? For Beston's carbonization plant, it can not only to process biomass materials, but it can also process the sludge and other kinds of waste. For detailed information, you can consult for Beston's team. Okay, now I will introduce you the whole system again. Firstly, let's begin with the feeding system. This is our feeding system. And now you can see this is a silo for the material. And the silo is suitable for the liquid material such as rice husk and wood chips, sawdust, and so on. And by the silo, you can fulfill the automatic feeding. No need the labor. Just by the silo, you can directly automatic to feeding the raw material. And closer to see the rice husk. The size of the rice husk is 3 to 5 millimeter, and the moisture is 9 to 12%. And normally, Beston recommend you to process the biomass material with a size less than 20 millimeter, and 8 to 12 millimeter is best. And the moisture should be less than 15%. I'm not sure. I understood. 5 kg for two to comply with customers' requirements. Can you advise us why do you want to do the test, and you want to get which kinds of data from the test. Normally, by our factory's test, we can only provide you the charcoal yard of your material. So 5 kg to 10 kg is enough for the laboratory test. By the laboratory test, we can help you to check the charcoal yard of your material. How big is BST system? I didn't got you very clearly, Ola. For BST, we have many models, such as BST10. The capacity is 1 ton material input per hour, and we also have BIT30 and BIT50. In there, much heat coming off the chamber. Actually, I didn't got you clearly, Tom. Can you explain in details for this question? Thanks. And now we go back to the work process of this machine. Now the rest husk is feeding into the reactor, and the rest husk will go into the reactor by this position and by the airlock valve. By the airlock valve, it can prevent the air enter to the carbonization system, and it means that there is no oxygen in the whole system for the carbonization system, so that it is safe and stable. Because the carbonization is running in the situation without any oxygen, and the rest husk will directly enter to the inner layer of the carbonization reactor, and go this way to the back of the inner layer, and then the material will be dropped into the outer layer and go this way to back to there, and then during this process, the biochar will be produced, and the carbonation time will be about 15 to 20 minutes. And now the biochar is produced, and the biochar will go from this position, and the biochar will be cooled down by the water cooling discharger. This is the water cooling discharger. By the water cooling discharger, the biochar will be cooled down, and then the biochar will be discharged at there and be stored in the tank. Now you can see the biochar produced from the rest husk material. The size and the shape is similar with the rest husk, and it's very dry. It's very dry. From there, you can see the rest husk material and the biochar, rest husk biochar. The comparison. Okay. Now let me check the comment. Ola said that, do we have opportunity to see the system in Europe? Ola, actually, we have many customers in Europe and running this machine. But if you want to visit their operating site, we must to get their allowance. So Beston cannot decide it, but we can contact with our customers for confirming, okay? You can contact with your sales consultant and for confirming. After carbonizing, do the complete EBC program of tasks. Okay, so you can send us the material, and we will do the combination test for you, and then you will get the voucher from your material, and we can send you the voucher back to you, and you can take the voucher produced to do the EBC test again. But for the amount, it depends on how many terms you want to do for the EBC program. So it's better to firstly to confirm the EBC program of tests, the requirement, okay? If you have confirmed the requirement, please inform us, and our consultant will confirm with you and give you the answer how many tons of material is recommended to send us. Okay, now we back to the work process of the combination system. Now we have got the voucher idea, and then you will also get the biogas idea. The biogas will be produced from the carbonation reactor, and the biogas will go through this pipe and go to the next system, the cyclone digester system. By the cyclone digester system, the biogas will be cleaned, and then the cleaned biogas will go through this pipe and go back through the yellow pipes. There are some yellow pipes connected with our combustion chamber in the reactor, and the biogas will be directly to be burning to heat the reactor of the carbonation plant, so that you can save some heating fuel, and just using the biogas heating the carbonation plant is enough. Normally, 1 ton of biomass will produce 70% of biogas, and the biogas is definitely enough for heating the reactor. Normally, about 70 to 80% of biogas will be recycling to heating the reactor, and the excess biogas will be induced to our excess biogas combustion chamber. This is the excess biogas combustion chamber, and there the excess biogas will be burned in the combustion chamber. And now we go back to the comment. Can we use most standard and mustard and not rest task for manufacturing? What is the output percent that we will get as compared to input? What is the fixed carbon percentage that we get from machine? Okay, for this question, actually, I think you can use the material for manufacturing, but it's better to send us some information and pictures of your material for double checking with our product manager, because most of the biomass material can be processed by our carbonation plant, but we must to ensure the size and the moisture can meet our requirement, okay? And for the output percent, based on the moisture of 10% of your material, normally the output will be biochar, and the percent of the end products will be biochar and biogas, and the percent will be 30% of bell charcoal and 70% of bell gas. What's the fixed carbon percentage that we get from this machine? Actually, for the fixed carbon percentage, it's influenced by your material highly. So it's not fixed. It needs to be confirmed after confirming your material. I'll do the test to make sure to judge the fixed carbon percentage. We'd like to see your system in China, can we? Hi, Ola. We welcome you to come back to China and see our machine in China. We are located in China, Henan province. And now we are in our Xiangqiu factory and our head office in Henan, Zhengzhou province. You can go to China and find us, and we will take you to see our factory and the production progress of this machine. Welcome you anytime. And now we have talked about the bell charcoal and the bell gas, and now we move on the exhaust gas system, the last system. The exhaust gas will be produced from the combination plant, and this is the exhaust gas pipe, and in the right side there is another exhaust gas pipe, and the exhaust gas will go through these two paths and enter to the cyclone deduster system. By the cyclone deduster system, the exhaust gas will be firstly be cleaned, and then the exhaust gas will go through the flue condenser system. By the flue condenser system, the temperature of the exhaust gas will be reduced to be lower, and then the exhaust gas will go into the next system. It's the dedusting system, and then by the dedusting system, you will get the and then by the dedusting system, the gas will be cleaned, and the white gas will be discharged from the chimney. Okay, the whole work process of our carbonization plant is over. And if you have any question for this machine, please comment in our live show room. When we got it, we will answer you. And my colleague Vivian will go on to talk with you later. Bye bye. See you later.
Okay, dear friends, how time flies. It's almost 8 o'clock. It's the time is drawing near to the end of this time live show. So, is there any question? Is there any questions else? Please comment on the comment area. And if there is someone would like to know the process again, and I will introduce the whole production line again. And the last 8 minutes. Okay, come on. Okay, let me check if there is any questions. Okay. What is the last question? What is the last question? Okay. Okay, friend. There is another question here, which is from Mr. Tom. If you stand next to the reactor chamber, can you feel any heat, or is it all contained and no external heat is felt? Oh, okay. For this question, I will show you. I will let you know the temperature. You can feel it. Okay, follow me. This is our engineer, Mr. Lee. And he will show you the temperature here. Mr. Lee, and you show the temperature. Okay, here. Okay, this. What is temperature? It's about 54, 60, about 60. Oh, now it's fixed in 61.8 degrees centigrade. Oh, okay. Okay. Okay, friend, at the end of the live show, please remember to pay attention to the official account of our YouTube, Beston Group. Okay. Let me show you. Remember to subscribe our Beston Group. Okay. Okay, Beston Group. Subscribe here, and after that, you will enter into our page, our main page of our YouTube here, and just click this arrow, just click this direction mark, and you will got the first page, the main page of the information of our Beston Group here, and through this you can see our contact way. Our website, our email, and our phone. You can contact us in time for more details. Okay. Okay, this is about the end of the live show. Okay, Ariel, come here. Okay. Okay, welcome to our live show next time, and we thanks for your attention to our live show this time. Thanks and bye for now. See you next time. Bye bye. Okay. 啊，终于播完了。